Okay, so we have our arithmetic sequence, right? Essentially, once you start to plug things in, you can simplify your equation. Okay, so for instance, just an example. Say we're trying to find t at n, so maybe it's the 8th term we're trying to look for. Let's say the first term was the number 5 we started at. Okay, so that was our first term. And we're looking for the 8th term. So that would be our n. N is our 8th term. So that's 8 up the sequence. Subtract by 1 because of our original term. And we'll say that the common, our common difference goes up by 5. Okay, so we have this here. Essentially, this whole thing, this entire thing simplifies. 5, this becomes 7 by 5. 5 plus 35, 40. Did you follow that? Okay. So essentially, if you think of it like we're making our own pattern, our first term was 5 and we constantly increase by 5. So that's our first term. Second term, third, fourth, fifth, sixth, 7. We got to get to 8 here. So 5, 10, 15, 20, 25, 30, 35, and finally 40. That's the idea between the pattern. So we get to our 8th term. So they have a question, question number 2, and they've given us t at n is equal to 3n subtract 2. Okay? There are several ways you can think of this. I guess the best way is we're trying to figure out, have they asked us specifically what they want us to determine? Rate of change between consecutive pairs. So you could think of this as maybe their first term was 0. There are several ways to get to a number like this. So let's say our first term a was 0. Okay? And then plus, this is our nth term. You know what, I should write the original equation just so this makes sense, because I'm doing a lot of it in there. Think of it like this. Our equation is our t at n is equal to a plus n minus 1 times t, right? What's happened here is they haven't found a value for n. Let's say we don't know which term we're trying to discover is right now. So our n is unknown, okay? But clearly from this, there's been some kind of distribution here. It looks like this d, whatever that term in, has been distributed because now there is a coefficient in front of the n. And it looks like they had some type of a term, okay? Now there's many different ways this could have came about, but let's just think of a specific example right now. So for instance, let's say we don't know what our a is, but because our n in our equation, I can show it right from here. Our equation, do you know what the coefficient is in front of the n right now?
3.
Right now, in the specific like skeleton equation. It's 1, right?
Yeah.
So if we were to make it 3, obviously our d needs to be what? 3 when we go to distribute it, yeah. So our d is going to need to be a 3. So when we go to distribute that, let's think of it as we have 3n, and then if that's a 3, that's going to make the 1 negative 3, correct? Okay. So we're pretty much here. The only difference now is they have negative 2 when we seem to have negative 3. To get to where they are, what would that mean our a probably has to be? Yeah, it needs to be a 1, because if that's 1, we end up with this. 3n minus 3. Well, we can't combine 3n. Yeah, okay, negative 2. So this is most likely what they were dealing with, okay? So what was the common difference in the numbers we were dealing with in this equation? What is our common difference? Or in other words, what's the pattern moving by? What was our d?
3?
Yeah, our d was 3, pretty much the coefficient in front of n. That's what's going to let us know what it is. This is a little harder to track. Well, actually not really, but this works out fine. This is our common difference, our 3. So that's what essentially they're looking for in those types of questions. Now they've gone more and more in depth in each question there, but that's essentially what they wanted you to find, the 3. So you had to almost work backwards from what they were trying to do. Does that? Okay. So with arithmetic sequences, right? Think of this, what we've written here. Do you remember your old linear equation? Y equals mx plus b. Yeah. Think of it like that. Really, this is essentially with different variables a y equals mx plus b relationship, right? This is our slope in a sense, and this is our y-intercept, right? Our y-intercept is -2, our slope is 3 over 1. You could think of it like that if you want to graph it. But what's really important is it's going to make a consistent line, whether it's positive or a negative slope. We have some type of thing like that. So let's quickly look at the other ones, okay? If I look at 2b, they've given us the equation of t at n is equal to 5 to the power of n minus 1. This is an exponential. So in other words, exponential, you've covered that before. If we're looking at a graph for an exponential, it's essentially something like this, and then it's going to take off like that. That's an exponential graph, not linear. So the question says to only deal with arithmetic sequences, so we don't even have to deal with question 2b. Okay, let's move on to 2c. 2c has t at n is equal to -4 n plus 7. Does this resemble a y equals mx plus b? Yeah, it resembles a y equals mx plus b. Now let's try to figure out, they want for each determine the rate of change between pairs of consecutive. Rate of change is also known as your slope. So it's quite easy. If we look at this and I can determine what my slope would be, that would be my rate of change. So for this specific question, what would the rate of change be for this question? Yeah, simple as that. Rise over run, we'd have a rate of change, so r of c of -4. That's our rate of change in c. Okay.
Do I have to like show my work?
Essentially, the only work you could show is like an estimation of where they started from, so work backwards. I don't think she wants. The rate of change is very straightforward. I don't think she wants much work shown for that. This is just the idea. I wanted to make sure you had an idea of what we were trying to do. Question D, t at n. I think this will make more sense when I FOIL it for you. When we get a squared, essentially it's going to be n squared minus 1. Because the other two ends are so that's that FOILed. Do you remember what type of graph something like that would make? It would be like this. Do you remember these?
Yeah.
This is a quadratic. It creates a parabola. Parabolas are not linear, so is this a arithmetic sequence? Not arithmetic sequence, so we don't have to deal with that question. Okay, D, E. T at n equals 1/2 n plus 2. Does this resemble a y equals mx plus b?
Yeah.
Yeah, very good. Rate of change, easy, 1/2. And finally F.
That you can't do.
No, we're going to have like a sideways parabola or something like that. It's not going to work. So we'll get n plus 2 over n, not arithmetic. So really, what she may want you to do is like question with D, you would have to say like not, blah, blah, blah. Okay? And same idea, not an A, we'll say. Okay? Not arithmetic. So we wouldn't deal with this question. Does that make sense?
Yeah.
Okay, let's take a look at 3. Sparks?
Yeah.
Okay. What did you discover as your for 3A?
Increases by 5.
So common difference, which is, let's write out our equation. It's always good to have, right? Okay. Common difference, which is which variable?
Which is D.
D. Yeah. What is our D?
5.
5. Is it positive or negative?
Positive.
Okay, that's important. Always make sure, is it going up or down? Okay. Second question, general term. What do they mean by general term?
Like the equation?
What do you mean by the equation? Okay, so general term, what they're talking about is a simplified version of this equation. Okay, so let's say we're going to plug numbers into this equation. We discovered our D. D is positive 5. Our A will be what on 3A? Yeah, A was the first term, or the first number, and we start with 5. So let's start working with this. T at n is equal to 5 plus n minus 1. And D, is 5. Right? Now, general term, they don't want us to solve for n yet. Let's make a simplified version. So we have 5 plus 5n minus 5. Does that make sense to you?
Yeah.
Because all I did was I distributed this 5 into brackets. And now finally, we're going to simplify that. What does that end up becoming?
It becomes
5n, that's it. So our general term is, they may want you to include the t at n. T at n equals 5n. And it's simple as that. Now finally, question C asks us for t at 10, correct?
Mm-hmm.
So what that means, once you have your general term, t...
Just plugging in with that.
Yeah,
10.
so that's exactly it. This n here, that little subscript there, refers to the variable n in the equation. So because the subscript is 10 in this instance, the n in our equation then becomes the number 10. So our t at 10, or in other words, the 10th term, is 50. That's simple. Does that make sense?
Yeah.
Let's try another one. So your interest rate in such question, interest rate is equal to your principal times your essentially your interest rate over the amount of time. So this is your interest earned. In this question, at the end of the year, your interest was $5 earned. The original deposit was $250. Okay. We're trying to find the interest rate, and we know it all occurred over the course of 1 year, it looks like. So t time was 1 year. They want you to solve for r. So really this can be rewritten to look like 50 times r times 1. Now we know the 1's not going to change anything. Well, 5 is equal to 250r when we're going to multiply it. Because we have to isolate by r, 5 divided by 250 is equal to r. Your interest rate, what do they have, is 0.02. So in other words, your interest rate is 2% a year. It's a pretty simple idea. You just have to be able to tell what is what. P stands for principal, which is your initial amount. That's what P is. So P is, think of it like your T at 1, okay, or first term, or in financial math they call it your initial amount or principal. I don't know if it's PAL or PLE. I think it's PLE. Is it? What's the principal of the school? Principal of the school is PLE?
Oh no, because in the textbook it's weird, because I swear in the principal, like in the school, is AL, and like the principal as a law is like LE. But in the book it's like AL.
Okay, so your principal amount, okay. The amount or your first term idea. I is the interest earned, okay? Interest earned. R is interest rate. Rate, right? Whether it's percentage. You have to turn it into a decimal if you're going to put it into the equation. And T stands for time. But what's important is you have to realize that interest rate is subject to time. Okay, and what that means is they may tell you have an interest rate of $5 or 5% a month,
which is like 0.05.
Yeah, which is a decimal is 0.05. So we'll write this in red. Okay. So let's say they're giving you a question where your interest rate is 5% per month. Okay. Just want to make sure you can relate this to time, which is a decimal 0.05, and they tell you how much interest do they earn in a year. Okay. If they tell you that in a year, your time is then what?
Like in minutes or like?
Well, what is your t going to be equal to? It's a specific number. T is, think of t as almost like periods. How many periods do they earn interest over? If they want to know how much they've earned in a year and they get interest every month, how many periods occur in a year?
12.
Yeah, 12. That's the idea, okay? So that's where t can be confusing. A lot of times you'll read a question 5% a month and they'll say how much do they get in a year? Many people will be like, okay, 1 year, well, t is 1, right? Many people will think of it like that. But if they're telling you per month or per day, that's not what t is going to equal. T is an arbitrary number. It's not always going to be measured in years a month. It's subject to what interest rate is covered in. So if interest rate, like I said, is 5% per month, well, in that case, if they want to know a year time, that means t is 12. If it was per day, and they want to know a year's time, well then t is 365, right? T constantly changes depending on your interest rate, how often you occur.
Will it always be in the year?
No, they could say in 10 years. They could say in 15 months.
Like, could be
You have to be careful. You have to read them carefully. That's the idea behind that. Does that make sense?
Yeah.
Okay. That's where you have to. That's where you get usually caught in financial math. Okay. Question 12. Let's turn it up a little. I can't quite read it. Bob opens a savings account with a deposit of $2,000. Great. That means principal is $2,000. Okay. The interest rate is 4.5. I'm assuming the /A means annually, which means per year. So interest rate is 4.5%, but when we go to plug it in, 0.045. We need to have it as a decimal, okay? And he does not make any other deposits. Oh, very easy. By what amount will the year-end balance in the account increase each year? So in other words, they want to know is how much interest does he earn each year. So our formula I equals P times R times T. Okay? They want to know how much is going to change per year. Well, our P is 2,000, our R is 0.05, and in our first question, A, T is 1. Very simple. So I equals 2,000 multiplied by 0.045 and multiplied by 1, which will change nothing. Let's quickly bring up the calculator. 2,000 times 0.045 equals 90. So what this is saying is every year his bank account will change by $90. In other words, it'll increase by $90. Okay? B. Write the sequence of the year-end balances for the first 5 years. Okay. So year 1, 2, 3, 4, and 5. Let's even write 0, just because I want me to understand the idea of 0. The idea of 0 is when you first put your money in, so you've earned no interest.
2,000.
Yeah, he's got 2,000. After 1 year, he's got what?
2,090.
2 years?
Yeah.
Yeah, you just add.
Yeah, you just keep on adding it.
Yeah. And what this works out good is it's just like our degrees. So it becomes easy to add. 2,450. That's our sequence. Okay. This is simple interest. Remember how I told you about the banks? He's only getting plus 90 every year. But in your bank account, they'll give you 4.5% on the new amount. So technically, on your bank account, you should go up more than 90. And then every year, if you're not making any changes, you should constantly increase. All these have increases of 90. Does that make sense? Okay. C. Determine the general term of this sequence. Okay? So let's try to set up our equation. T at n equals A plus n minus 1. Thanks. D. Good. What is our D?
Our D is 90.
Yep. And what is our A?
First term, right? So will it be 2,000?
That's it. It's 2,000. Okay. So let's find our general term now. I didn't talk through it because I knew you were doing it at the same time.
Yeah.
Did you end up getting?
Yeah.
Yes? Okay.
Oh, that was easy.
Yeah. Very simple. Okay, let's go to D.
Graph the sequence.
Graph the sequence. Let's I'm gonna assume you know how to do that. Can you do that?
It's really easy because it's linear, right?
Yeah, exactly. Okay. And
at the end of 1 year, the balance in the account is 3,350. How many years?
Oh.
The original
he's not saying at the end of 1 year. He's saying at the end of a specific year. They worded that funny. So what they mean is at the end of a specific year, the amount is 3,350.
Do you just plug that in N?
No, we don't plug that in N. N is the number of periods again, okay? So what it's saying is our T at N, in this question, they're saying T at N is equal to $3,350.
Oh, yeah.
Okay? But what we don't know is we don't know how many terms have passed. So we keep our general term of 9N plus, and what we're trying to figure out is how many years has this passed,
So
okay?
you just isolate for N.
Isolate for N. So we bring this over. I'll probably solve it faster than me. Oops. So, 3 times 0. I'm just going to record what I'm doing just so you can see it again.
Mm-hmm. 160.
So as you got, equals 9n, and then when you divide by n, what is it? Sorry?
160.
160. So what does that mean?
So like it's 160 in like
How many years have passed?
160.
160. So look, he started at $2,000. It took 160 years to get up to $350. This is really a good investment. That's brutal. You don't, like, he almost doubled it, which does make sense, but because you have such a small interest rate and such a small principal, it's not a lot of money. You didn't really make a lot, right? So really,
die.
yeah, oh yeah, no one's living that long. Left it for his kids, and they're probably not very impressed. Let's do her question 14 here. Good. Number 14. Okay. Question says a pile of bricks has 85 bricks on the bottom row. So 85 bricks, bottom row. Okay. And then 81 bricks on the second row. 81 bricks on second row. And 77 on the third. Now, actually, this isn't quite what she has, but let's
Oh, it's this one.
yeah, that's what we're looking for. Let's skip 14. Let's go to 17. 17 is more the question she's looking at, because even 14 is actually not that hard. 17. Okay. Question 17. T at 6 is equal to 23. T at 11 is equal to 38. This is 17a. Okay. Okay. So what we need to do is we need to set up our questions. We know our formula is T at n is equal to a plus n minus 1 times d. Right? So we're going to use that formula twice. I need to do it also over here.
You have to do it twice?
I got to do it twice. Okay. What we're setting up is a linear system, and we're going to solve for the point of intersection. So T at 6 is 23. So in other words, n is equal to 6, and T at n is 23 in this one. So 23 equals a plus 6 minus 1 times d. In our other question, T at 11 is 38. So T at n is 38, and our n is 11 in that case. So let's find our general term again. Okay, so what we're going to do is we're going to try to isolate for one of the variables. In this instance, let's say we're going to isolate, I think they specifically isolate for A. We could do D. What do they do? Oh, they do, okay.
They expanded D
Let's
over.
isolate for an A. Do you remember, do you know how to solve through substitution? They solve through elimination. Linear system.
Substitution, I don't. It's like, so I kind of forgot.
Okay, let's simplify this first. So let's simplify this. This becomes 23 equals A plus 5D. Well, in this instance, we have 38 equals A plus 10D. Okay. Now, elimination is getting rid of one of the variables and solving for another one. Substitution is setting one equation equal to a variable and then plugging it in.
Isn't it elimination easier?
It can be. The elimination can be a lot easier. In fact, elimination is easy in this instance because we both have A's. So let's say
What if there's a number
in front of the A? Then you can multiply an entire equation by a number to get them the same to subtract or add. Okay, but in this instance, both our A's are the same. And whenever we run into questions like this, both the A's will be the same because we don't know what it is. So we won't put a coefficient in front. Yeah, they should be. There shouldn't be, unless they really word it differently. It'll have to be a word problem where the A wouldn't be. If they set it up like they have here, T at 6 equals and T at 11, all of the A's will be 1. So we put the two above each other. We have 23 equals A plus 5 at D. 38 equals A plus 10 at D. Okay? Now what I'm going to do is I'm going to subtract these. So in other words, I'm just going to go straight up and down. 23 subtract 38 is negative 15. A subtract A is 0. Cancels each other out. And 5D subtract 10D is negative 5D. Okay? So now I have an equation that says negative 15 is equal to negative 5D. Well, I need to find out what D is. So I bring negative 5 over. What do I get?
Negative 3?
Close. Negative divided by a negative.
Oh, positive 3.
That's right. So D is 3. Okay? So we've now discovered D. So let's go back to our equations and
then plug it in.
Let's plug it in.
A.
Yeah, so we have a D. We can choose either of the equations they originally gave us to solve this. Oh, way too high. So I can choose either the first one here, or I can choose the second one here. Okay? Let's just do the first one. 23 equals A plus 5D, this one here. We're going to take that one there, okay? Let's see. 23 equals A plus 5D. We know D is 3, so we substitute that value in for D. 23 equals A plus 5 times 3, which is 15. So 23 equals A plus 15. Bring the 15 over.
8.
Yep. A equals 8. Okay. So now we have A and we have D. We can set up our actual equation. Remember, our T at n equals A plus n minus 1 times D. We know D is 3, and we know A is 8. 8 plus n minus 1, D was 3. We distribute the 3. It turns out our term is T at n is equal to 3n plus 5. That's our general term. Does that kind of make sense? Okay.